Good morning, everyone. Good morning. Hiranmay, Tanuj, Vardhan, Varshini, Rahman. How are you all? All good? So, next class of chemical bonding chapter. Sai. Good. Okay, nice. So, Sunday we have the test. They have given in the syllabus. VBT, Vesper theory, hybridization. Mainly this topic can come. Okay? So in the last class, what we have studied in the last class, do you remember something? Good, all good, all good. All of you are awake? Still someone is sleeping? On the bed only? Sir, it takes 15-20 minutes time to wake up. Morning classes. But you are at home, na? Your parents will wake you up. VBT we have studied. Correct. So VBT, I think we have written last point, calculation of some sigma and pi bonds. Calcium carbide I have told you. Okay, that energy diagram we have told you. I told you to do some questions. Did you find that energy diagram questions in PYQ? Have you found it? Energy diagram questions. Batao? You'll have to search, na? VBT questions. Whatever you get, solve all. In the module it is there. Okay, good. So those who are solving module, good. Sorry. So if any book is also there, they will also mention all those questions. Okay. Something you will have to solve. Something you will have to solve. Okay, some questions you will have to solve because only theory part will not help you. We are doing some questions in the class, but you will have to also solve some extra questions. So follow the gym material or follow any book. JEE Mains questions also you can do. PYQ questions are there. You can try for every chapter. Those who are joining late, we will say you you can watch the previous videos. As all the videos are public, so you can watch all the videos. First 4 videos are like warm up. They will tell you about Z effective, radius, ionization energy, electron enthalpy. Basic. We have not done periodic table till now, so don't think like this, keep periodic table over or what. We have not studied periodic table. We will teach you. Okay. And bonding chapter we are doing. Bonding chapter we have started. Bonding chapter till now you can say one major topic we have done, that is VBT. Rest parts you are already knowing. We will do the second important topic today, that is your Vesper theory. Okay. Anywhere you feel ki, this point I have missed, so you can ask your doubts in class, or you can watch the video once again. Okay? If you feel ki speed is a bit more, then decrease the speed. Take 0.75x you can watch. If you think speed is very slow, then you can increase the speed. So there are some benefits of attending online lectures, na? So we can do these things. Everything is okay, no problem. Last year module, this year module, your choice. Some upgradation are there in this year module. Okay. So let's start. So see, we have to write one more point today when we will see some questions can be there based on this. ठीक है, strength of overlap. We have done positive negative overlap and all. We have said कि in case of positive overlap bond will be formed. In case of positive overlap bond will be formed. We have to consider bond formation only in case of positive overlap. ठीक है? We have done this also, internuclear axis. What is internuclear axis? Which orbitals are coming, then which bond will be formed, sigma bond, pi bond. We have also said about delta bond, I think. Nahin? Delta bond we have said ki when all the four lobes of one orbital will overlap, then that is what? Delta bond. One lobe of one orbital overlap. One lobe means what? Sigma bond. Like see, we have said that this is p orbital, two lobes are there, one lobe, second lobe. Two lobes are there. Whenever one lobe of each orbital overlap, one lobe, that means sigma bond. If two lobes overlap, see here, one lobe, two lobe overlap, then pi bond. If all four lobes overlap, then this is what? Delta bond. Delta bond we have said generally not given much in NCERT. In molecular orbital part they have used the name. Okay? So you can see it. Chalo. Now see what we will do. Today we are going to see, we have seen, okay sir, SS overlap I am knowing sir, SP overlap I am knowing sir, PP overlap I am knowing sir. But can you tell me, sir, by which overlap bond will be stronger? By which overlap bond will be stronger? So there are 2-3 questions based on this point also. So see these things carefully. I am talking about strength of overlap. Strength of overlap. Like which overlap will be stronger? Which overlap will be stronger? We will divide into two parts. First part, when n is constant. N is constant means what? Orbit number. Orbit number is what? Constant. ठीक है? If orbit number is constant, then PP is stronger than SP is stronger than SS. Means P is better than S. P is better than S. P is better than S. When n is same, like for example, I will give you, suppose you are having 2p overlap. Some case you are having 2p overlap. Okay, some case if you are having 2s overlap, and some case you are having suppose 2s overlap. So when you will find in these cases, you will find कि sir principal quantum number, orbit number तो same 2. Orbit number, principal quantum number is what? Same. Then we have told you कि भाई PP is better, stronger, better effective overlap as compared to SP, as compared to SS, like this. ठीक है? Then you will ask, sir, if n is not same, then what will happen? Array, if n is not same, n is variable, principal quantum number is variable, then smaller n, more strength, better overlapping. ठीक है ना? So strength is inversely proportional to n. Smaller n means better overlapping. We know this also कि as the value of n increases, size of orbital increases. Like see here, this is 2s, this is 3s. Both are s orbital, both are spherical. But as orbit number increases, size of orbital increases. Now see, suppose when we are going to do pairing, orbitals will have one electron. So this will have one electron, this will also have one electron. Okay, electron density will be there, like we can say like this. Here also electron density will be there. In which case electron density will be more? Both are having same number of electron. One electron here, one electron here. One electron here, one electron here. Tell me which will have more electron density? Which will have more electron density? 2s or 3s? Electron number same, it's all about volume now. 2s have more electron density? More electron density. More electron density is there. Okay? So now suppose other orbital is coming and it is overlapping this much part. This much part I am talking. Other orbital is coming and it is overlapping, suppose this much part. And same orbital is going and overlapping with the other also that much part. So you can clearly see in this diagram in which case you are getting more electron cloud. In which case you are getting more electron cloud, first overlap or second overlap? First overlap or second overlap? In which case? By the diagram you can say, see and tell. In which case you are getting, when you are overlapping, see same area I have overlapped, same area, same volume. Okay, na? So in which case you got more electron cloud? First case, here so you will see here sir very less, not visible also something. But here you are getting some cloud or not. So that's why we say if the smaller orbital is there, then electron density is more. Okay? Electron density is more. Like you think like this, a big ground is there. A big ground is there. And suppose in that big ground 10 people are there. Okay, na? And something unfortunate thing happens there. Then less damage chances because it is not crowded. Na? Density is what? Less. You see many places means stampede news and all. Crowd is less, density of people is less, less damage, less effect. But suppose one small area is there and so much crowd is there, that those 10 people only you keep in one room, small room, then density is what? More. Anything happens in that room, all 10 will be trapped. Okay? So more electron density, better overlapping. So we have said this. So now you don't have to check SP first. You have to check orbit number. Like see, I have written here, suppose you are having 3p overlap and you are having 2s overlap and you are having 1s overlap. Can you tell me the order? Which overlap will be stronger? Which overlap will be stronger? Bolo, tell. Which overlap will be stronger? So here you don't have to think like this. Sir, PP, you have said, sir, PP. Array, I have also said that orbit number should be same. Here third orbit, here second orbit, there first orbit. Orbit numbers are what? Different. And if orbit numbers are different, then smaller orbit, better effective overlapping, stronger bond. Because here why? If they will ask you, sir, why 1s overlap results in stronger bond? 1s overlap results in stronger bond. How you will justify? Bolo. Meghna, Sudeshna, Pranita, Rahman. Achha, one thing I will tell all the students, if you are planning to take admission and all, and you are on the borderline or means you are in dilemma, what I should do, then also you should attend at least online lectures. ना, कि मान लो you are getting selected, you get the seat, leave. If unfortunately you don't get the seat, then at least you have not missed the lectures, you have not wasted the time. So you should start watching the online videos at least quickly. By the time you are at home, you should watch all these things instead of wasting time. Otherwise, what you will see? You will see the reel of here, there, this, that, fighting going on. So you'll have to say here ki by here we have more electron density. That's why overlapping is what? Better. Clear? Any counseling dates and all they have informed? Bolo. Acha. Then some people will say, sir, मान लो if there is 3s, 3p, and here we have 2s, and then we have 2s and we have 2s. Then who will be better overlap? Who will have better overlap? First one, second one. You have to tell this. First one, second one. Not yet announced, na? Okay, don't worry. So again, you have to think like this. See, this 2s, 2s to fixed only. This 2s, 2s to fixed. Here 3p and 2s. 3p and 2s. 3p and 2s. Then you have to check what? Orbit. Smaller orbit, better overlap. Smaller orbit, better overlap. Smaller orbit, better overlap. So like this, you can do some questions. Okay. So let's do 1-2 questions. Dhyan se suno. As I have told you the difference between sigma and pi bond also I have told you. Sigma bond is stronger, first sigma bond is formed, then pi bond is formed. According to VBT, no pi without sigma. All these things told to you. Okay, na? Okay. So I am giving you this question now. Everyone see and tell something. Ki मान लो I am talking about strength. I am talking about strength. Okay. And the first question is, I am comparing CC bond like this. Can you tell me which will be stronger? First one, second one. Can you tell which will be stronger? First one, second one. And people come in class at time, okay? Because you see, slowly if you are coming, you will miss initial 10-15 minutes. It will be difficult to correct. Okay? So problem can be there. Bolo, first one is stronger or second one is stronger? First one is stronger or second one is stronger? Batao. Second one. Okay? But many people give wrong answer in this also. We are smart enough to tell कि sir second one to double bond stronger. But many people what they think, mainly juniors and some senior long term people also. Just after this topic they think like this, sir, this is sigma bond. Sigma bond is stronger than pi bond. They will think like this when anyone read for the first time. When anyone read for the first time, then they see like this, sir, this is sigma bond, this is pi bond, sir. Sigma bond is stronger, sir. You have said. Arey, this is not a comparison between sigma and pi. This is a comparison between single bond and double bond. This is a comparison between single bond and double bond. Clear? This is a comparison between single bond and double bond, not between sigma pi. This is not pi bond. Batao, is this a pi bond? No, this is both. One is sigma, other is pi. So you are not comparing between sigma pi, you are comparing between sigma single and double bond. See, we have said na, if density is more and some area you overlap, then you will get more electron cloud there. Here density is less, you overlapped. See, very less electron cloud, even not one dot also did not came in this. So I said if the density is more, मान here I increase, मान more density is there. So see, in this overlap region, you are getting more electron cloud. But in this case, density is less, very less electron cloud you are getting. That's why this one is weaker. So now you have understood that this is not a comparison between sigma and pi. This is a comparison between single and double. Again, if I will give you like this, so this is triple bond. Triple bond is what? Stronger. If you will check the bond energy data, this will come around मान लो 360, 400. This will be around 700. This will be around 900. Bond energy, total bond dissociation energy. Okay, clear to everyone? Acha, but if I ask you something like this, ki assume this down bond is sigma and up bond is pi. Down bond is sigma, up bond is pi. Assume down bond is sigma, up bond is pi. Then which one is stronger? Up, down. Bolo. Then which one is stronger? Down, up. So if I ask you like that, then you will say, sir, down is sigma, up is pi, sigma bond is stronger. But don't think like this. This is single bond and double bond comparison. Okay. Next point. One more thing you have to think like this. See, whenever we are comparing this, so you have to take the same type of bond is formed. Like we are knowing SS. मान लो if this SS overlapping takes place, then can you tell me which bond will be formed, sigma or pi? SS overlapping done. Any axis you take, which bond will be formed? बोलते रहो, say quickly, keep writing. Sigma. Here which bond is formed? Sigma. Here which bond is formed? You will say, sir, here to both can be formed, sigma as well as pi. Okay, sigma as well as pi. So we have to compare sigma. We have to compare what? Sigma, same nature of bond. You don't have to do like this, sir, this one pi. Then how you have said? It is understood that this is sigma and this the only sigma possibility is there. So I have taken sigma of this and sigma here. Now I am comparing. Generally in question they mention this also. Ki we are talking about sigma bond, tell me the strength of overlapping. Clear? If they don't mention, then we will assume on our own. Like if I ask you next question, देखो ध्यान, see here. मान लो if I ask you SS overlap and PP overlap, which one is stronger? SS overlap and PP overlap, which one is stronger? Bolo, tell. Which one is stronger? You will say, sir, just now you have said PP. Assuming same nature of bond. Like here, so we have only one chance. SS means what? Sigma bond. Here we have two chance, sigma or pi. I will take sigma, compare. Then PP is better. Clear? Now see, one question is there in gym material. They write the same thing, SS. Here they write same thing, PP. But beside this, slowly they write collateral. Slowly they write here collateral. Now you tell me which overlapping is stronger. Now you tell me which overlapping is stronger. Everyone should try to answer. Which overlapping is stronger? So here you will have to say, ki sir, SS to sigma bond only one possibility sigma. PP both are possible. But here they have mentioned collateral, that means sidewise overlap. That means this is sigma bond, but here they are talking about pi bond, and sigma and pi bond, sigma is stronger. We don't have to see here PPSS. Sigma is stronger than pi. So if they write something like this, so this is a comparison between sigma and pi. Here we have assumed both sigma. Clear to everyone? So such kind of twist can be also given. So don't mug up the things. People remember PP. This will come, you will tick PP. So see the concept behind it. Clear to everyone? Okay. That's it then. So strength of overlap we have explained. Okay. Let's come to this part. Okay. So you tell me some examples. Examples of SS overlap. What kind of overlap? Which orbitals are involved? Which orbitals are involved? This you have to tell. Like H2 is there, HCl is there, Cl2 is there, F2 is there. Then which orbitals are overlap? Orbitals, atomic orbitals involved. Can you tell me which atomic orbitals are involved in making these molecules? In making these molecules, which orbitals are involved? Like hydrogen is there, so you have to take the valence shell, valence orbital. Like here we'll say, sir, here the only one. So 1s and 1s overlap takes place. HCl is there, that H you have already said 1s. In Cl case, when you will write the configuration, 3s2, 3p5. 3s2, 3p5. Correct or not? I am saying correct now. So 3p5 is having one unpaired electron. So here 1s 3p. I am considering these things without hybridization. Keep in mind, I am considering these things without hybridization. Although here we will not face any problem, but that's why I have written here atomic orbital. Done? Okay. In Cl2 case, what you can say? Here you can say, sir, 3p, 3p. Here you can say what? Sir, 2p, 2p. So these type of questions can also come, in which case sp overlap taking place, in which case pp overlap taking place, and so on. Clear? Done. Okay. Now let's see one more question. Like suppose you have seen here HCl. How this bond is formed? So you can think like this. Let's write the configuration of HFHCl, whatever you write. I am writing about Cl. So this is neon, 17 electron, 3s2, 3p5. 3p5 orbital diagram you can write like this. Is it okay? Okay. First singly filled, then pairing takes place. This much we are knowing, bhai. This much you all know. So you can clearly see here one unpaired electron. Now what will happen? Hydrogen is there, 1s1. It will have one electron of opposite spin. And then what will happen? This 3p and 1s, they will what? Overlap. And they will pair. So this is ground state configuration. This is what? Ground state configuration of chlorine. This is ground state configuration of chlorine. In ground state, chlorine is having one unpaired electron. It can form one bond. In ground state, chlorine is having one unpaired electron. It can form one bond. Now if someone will say, sir, I want to make ClF3. I want to make ClF3. Then is chlorine making bond in ground state? Tell me. is chlorine making bond in ground state? Now to you are smart enough to tell. No sir, ground state to only one unpaired. Here to chlorine making 3 bonds. How it can be ground state? Okay, then how it is happening? So again you will write like this. Let's focus on 3p. Then you will think, sir, 3p na third orbit, third period. 3p is also there and 3d is also there. We are not filling 3d, but 3d is there. So you will have to do like this. Listen carefully. 1, 2, 3, 4, 5. Okay. 3d is empty. So now you will have to write excited state. First excited state. First excitation. First excitation, what will happen? See here, one electron from here will jump to 3d. One electron from here jump to 3d. Everyone see here. So the final configuration will look like this. Now can you see how many unpaired electrons are there? First excitation or second excitation? Sudeshna, Vardhan, Pranita. First excitation or second excitation required? First excitation state or second excitation state? So you have jumped electron only once. So 3 unpaired electrons, now this fluorine will come and bond with them. So in this case, chlorine is present in first excitation state. Chlorine is present in first excitation state. When you will jump one more electron, when you will jump the second electron, it is second excited state. Understood the point? So based on this, I will give you a question. Tell me, how many unpaired electrons? How many unpaired electron in second excited state? Second excited state of iodine. Iodine is there. Tell me how many unpaired electron in the second excited state. By who said second excited state? I am saying first only, na? First excitation, na? What first time you have done? So first excitation state. Tell me the answer of this question now. బోలో బోలో 1 2 3 4 5 5 options are there. So many people are giving correct answer. All should reply. Parents will beat you if you will not reply. ठीक है? You are at home. Okay. Anyone is there who is watching video taking breakfast also? Anyone is there who is eating breakfast? Yummy breakfast and watching video also? No one is there, na? Chalo. Tell me how many unpaired. So you will say कि सर ठीक है iodine sir, iodine तो configuration I don't know sir. अरे don't worry, I don't want exact configuration. You have to think only कि iodine is present in 17th group. 17th group present means what? 17th group present means P5. Iodine is what? P5, same case. So when you will do excitation, this is d orbital. When you will do excitation, everyone see here carefully. When you will do excitation one time, this electron will jump. Clear or not? ठीक है ना? This electron will jump. So this one is first excited state. Three unpaired electrons. Again you will jump one more. So this will generate second excited state. So in second excited state, 5 unpairs are there. 5 unpaired. So now you understand what is first excited state, second excited state. 5 unpaired, bhai. 5 unpaired. Clear to everyone? And here we will wind up this VBT part I. We will go to the next topic now, that is your Vesper theory. Clear to everyone? Aaja. So the next important topic we are going to start is Vesper theory, valence shell electron pair repulsion theory. ठीक है ना? Write the name, say the name. Valence shell electron pair repulsion theory. Valence shell electron pair repulsion theory. ठीक है? So now you will have to think. Take for 10, 15 seconds, 30 seconds, 40 second break. Try to digest all these things, then we will start. Okay? Take a short break. Very short. Ionic bond is non-directional. This you are knowing. Covalent bond is directional. 1-2 basic points we are knowing na कि covalent coordinate bond are directional. If they will ask to directional bond, covalent and coordinate. That's it. Ionic bond is non-directional. So this is one point which can come anywhere. Many places this point comes. So not to worry about it. We have told you that thing, properties of ionic compound. वो बताया था, conductor and all, bad conductor, good conductor. Do you remember? Told na? Okay. Okay, आ जाओ. Vesper theory. So introduced by Sidgwick and what? Powell. Sidgwick and Powell in 1940. Developed by Nihom, जो बोलना है बोल लो, whatever you want to say. Gillespie, whatever you want to say, your choice. In 1957. Main point is, sir, what is the use of this Vesper theory? Before this, so you have told us 2 rules, octet rule and VBT. Octet rule was just telling ki 8 electrons compulsory, 8 electrons required. But there was one drawback of octet rule, you remember? Octet rule was not able to tell shape of a molecule. Octet rule was not able to tell shape of a molecule. Shape you were not knowing. Tetrahedral, octahedral, trigonal, planar. What is the shape? This we are not knowing from octet rule. Okay. So this theory will tell you about the shape of a molecule, valence shell electron pair repulsion theory. It explains shape of a molecule. It explains shape of a molecule. This is the importance. Very important topic. You can say 30% chemical bonding is this topic only. 30 to 40, because other topics are based on this. Whenever you will study hybridization, they will ask about shape also. Whenever you will study dipole moment, you cannot do without shapes. Okay? So 30%, 40% weightage is this one, Vesper theory. So see it carefully, see it seriously, practice some questions. Okay? So it explains the shape. Achha, if I ask you why we studied VBT, then what you will say? What was the use of studying VBT? Skip the topic. Leave it. Why we studied VBT? Because VBT explains formation of covalent bond. VBT explains formation of covalent bond. How a covalent bond is formed. You saw here atoms coming nearby, potential energy decreasing. A time will come when potential energy is minimum. At that point, bond is formed. Who told these things? VBT. Clear? So everyone is having its role. VBT tells about how a covalent bond is formed. This tells about shape of a molecule, which was not told by octet. Clear? Okay. So let's start. How to start? From the names only many things are clear. Now everyone take out NCERT. NCERT should be always open. NCERT should be always open. You will have to write Vesper theory. Postulates. Clearly mentioned 6 points in NCERT. Clearly mentioned 6 points in NCERT. Okay, all those 6 points you have to write exactly same. All those 6 points we will explain exactly same from NCERT. So everyone take out NCERT, see those 6 points. First 3 points, so I can explain from the name. First 3 points most important, and we can explain it from the name. What you can explain? See here. What is the first point written in NCERT? I am telling you. Everyone open NCERT, page number 112. First point they will say कि shape of a molecule depends on valence shell electron pair. From the name only it is there कि shape depends on valence shell electron pair. Now valence shell electrons can be bonded pair or non-bonded pair. Like everyone will not take part in bonding, na? See here, like these are valence electrons. How many were taking part in bonding? You will say that 3 are taking part. This is left or not? So some are there as lone pair, some are taking part in bonding. They are saying shape depends on both. Shape depends on both. They will give you in the question. Shape of a molecule depends only on lone pair, not on bonding electron. True or false? You will say, sir, false. It depends on both. Bonded electron also, non-bonded electron also. Done. First point over. Second point. Second point they will write in NCERT. कि अरे this valence shell electron pair ना, they are repelling each other. They are repelling each other. Why they are repelling each other? Simple common sense. All are negatively charged. Same charge, repulsion. Repulsion will be there. So what is the first point? First point is there ki shape is told by valence shell electron pair. Bonded also, non-bonded also. Second point, these electrons are repelling each other. Why? All are negatively charged. Done. Third point. Now what is your target? What is your target? My target is to minimize repulsion. My target is to minimize repulsion. How I can minimize repulsion? By putting these electrons as far as possible. By putting these bonds as far as possible. So they will write the third point, ki minimize the repulsion by maximizing distance. Minimize the repulsion by maximizing distance. मान लो suppose two students are there in class fighting with each other always. How you will stop this fight? बताओ. How you will stop this fight? How teacher will stop? Teacher will make them sit as far as possible in the class. One child that corner, this child this corner. Fighting stopped. Similarly, I have to reduce the repulsion. Put the electrons as far as possible. Like suppose one atom is there. Suppose one molecule is there. Chalo, I am writing here BeCl2. You are knowing that beryllium is having two bonds. Till octet rule, you are making any diagram, dash, dash, someone making like this, someone making like this, someone making like this. Which one is correct? Then from octet rule, we were not knowing. But now we will tell you, these bonds are having electrons. These bonds are having electrons, bonded electrons. They will repel. They will repel. Then I have to maximize their distance. So the repulsion will be minimum. And I will get which shape? Linear. Angle what? 180. So this is the case when both the bonds will be far from each other. When both the bonds will be far from each other. Minimize repulsion by maximizing distance. So we will get the finally shape. Okay, shape is what? Linear. Shape is what? Linear. Clear? Now let's see what is written in NCERT. Aajao. So we will write exactly the same lines of NCERT. So what will happen na? Ki we will read NCERT, we will learn NCERT, question will be also from NCERT. So exactly same lines may come in the paper also. We are practicing exactly same lines. We will not face any problem. Let's see which chapter is this. Bonding. Yes. Aaya. So these all formal charge and all. Acha, you know one thing. Dekho bhai. This I am telling you one point. This formal charge thing na, this is written wrong in AP board NCERT. Combined NCERT we are having na, AP board 1. So there this point is written wrong. Wrong printed. Here it is half of bonded electrons. In that AP book NCERT, state book NCERT, they have written here half number of bonds. Not electrons they have written. Number of bonds they have written. So be careful about that. Chalo. All things done. So we will go to कहाँ गया भाई? Vesper theory. So these are the postulates written here. We will write exactly the same thing. 3 points already I have explained. You can verify कि sir telling correct or not. लो भाई, कर लो तुम verify. So what you find here? Shape of a molecule depends on number of valence shell electron pairs or not. Yes. Bonded and non-bonded both or not. Yes. Pairs of electron repel one another. Yes. Due to what? Negatively charged cloud. Done. Pairs what? Occupy what? Such position to minimize repulsion, maximize distance. Same to same, said in class. Done. So these 3 points are easy. These 3 points are important. After this also 3 points are there. A bit difficult to understand. You will feel here what they are saying. But don't worry, we will make you understand. ठीक है? आ जाओ. See here, next 3 points. In fact, we can tell 4 points. आ जाओ. 4 points we will tell like this. We will copy this one also. That's why I'm saying 4 points. Okay, remaining 4 points are here. Okay, 3 plus 1. Okay, now see what they are writing in these 3 points. Okay, they are writing these things. First point, they are saying like this. What we have said, they will follow that only. Sir, we have to minimize repulsion by maximizing what? Distance. Now they have just included here one new word. Ki assume the valence shell like a sphere. Assume the valence shell like a sphere. And you put the valence electrons as far as possible on this sphere only. Like here I have put the valence electrons as far as possible. So this only they are saying. So same thing to we were saying before also, the distance should be what? Maximum to minimize repulsion. Here they have just used what word? Ki assume the valence shell like a sphere. And you have to put the atoms or the valence electron on this sphere. The valence shell is taken as a sphere. So exactly this line they will ask, if they will ask. With the electron pair localizing on the spherical surface. Electron pair localizing on the spherical surface as far as possible. That's it. This is the 4th point. What is the 5th point? 5th point is like this. See, whenever you tell shape of a molecule is due to sigma bond. Shape of a molecule is due to sigma bond. Pi bond has almost no role. Pi bond has almost no role. So like see, I have made this diagram according to sigma bond, it is coming linear. If you make a pi bond here, then also what? It is linear. Then also what? It is linear. So pi bond has almost no role in telling the shape of a molecule, mainly told by sigma bonds. So that's why they are saying ki if there is double bond, triple bond, na, ignore. If there is double bond, triple bond, then ignore. Assume this double bond like a big single bond. Ki you think like this, ki 2 are not there. You see nicely, this is one only. You say, sir, this is a bit thick, sir. Assume it as one bond. Okay? Then you will say, sir, one bond, so 2 electrons are only there. Here, to 4 electrons are there. Double bond means what? 4 electron. Triple bond means what? 6 electron. Now people will say, ठीक है, sir, I have assumed this as one bond, big bond. But there are 4 electrons. Then I will say, ठीक है, those 4 electrons you think like a single super pair. Single super pair. Take an extraordinary pair. Take a single super pair. That's it. So they are saying that a multiple bond is treated as if it is a single electron pair. And the 2-3 electron pairs, because double bond, then 2 pairs are there, triple bond, then 3 pairs are there, are treated as single super pair. So if they will say you कि अरे what do you mean by single super pair? What you will say? बताओ तो, tell me once. What you will say if anyone comes to you and ask, tell me what is a single super pair? What you will say? Tell what you can say. Single super pair. You will say, sir, we can say multiple bond. Simple, you can say single super pair means what? Multiple bond is there. They will ask you in the question, ki who is having single pair? Who is having multiple bond? CO2 is having single super pair or not? Yes. Or you can say single super pair means exactly according to NCERT 4 electron or 6 electron. Double bond means how many electron? 4 electron. Triple bond means how many electrons? 6 electron. So single super pair means you can say 2 pairs, 4 electron, or you can say 6 electron. That means you can say 2 pairs, 3 pairs, which they have written. 2 or 3 electron pair are treated as single super pair. So this is the meaning. So all the lines of NCERT we are trying to make you understand. Then there is the last point. All these lines keep in mind. Last point they are saying some resonance. So you are knowing ki now to you are not means 11th class people, na? You are long term people. So at least you know something about resonance. Ki yes sir, I know different resonating structures are there. Like I can tell you ki like carbonate is there. Everyone will agree, sir, carbonate, this to given in NCERT, 3 resonating structures are there. So they are saying ki Vesper theory will be applied to all resonating structure. All resonating. If you make the second resonating structure, Vesper theory is applied here also. Means what? Here also maximize the distance, minimize the repulsion. So this one only written here, nothing new. When 2 or more resonating structures can represent a molecule, Vesper theory, Vesper model is applicable to any such structure. Vesper theory you have to apply to all resonating structure. Clear, simple, done. So are all these 6 points clear to everyone? Dekh lo, all 6 points clear to everyone. Okay, tell your friends also, bhai, share with your friends so that they can also learn. Okay, tell them, ask them some questions. Okay, today you go and ask your friend, Arey, do you know what is single super pair? Then he will say, single super pair, is it related to Superman, Superwoman? Huh? Like this also they can say. Don't be surprised. So you have to study. If you will not study, then you will have such doubts. Clear? आ जाओ. Okay, so next part. So some options I can ask you. Ki Vesper model is applied to maximum 3 resonating structures. Bolo true or false. If anyone is having 4 resonating structure, then Vesper model will be applied to only 3. Is it true? Huh? No. It will be applied to all. Okay? Okay, let's come to the next point. You will say, sir, last point here written something. You explain this one also once. What is this? Dekho, after this, the next story is there. We said na ki redefined. When you will read NCERT, here they will write ki that those scientists Nihom and Gillespie, whatever you say, this Nihom and Gillespie did something, redefined, something written here in NCERT. You see this. So they mainly told about lone pair and bonded pair. Lone pair and bonded pair. Ki valence electron can be 2 types. One is bonded pair, other is non-bonded. Non-bonded is also known as lone pair. So their main work was on bonded and non-bonded electron. See, written here, Newham and Gillespie refined the Vesper model by explaining important difference between lone pair and bonded pair of electron. While lone pair are localized on a central atom, each bonded pair is shared between two atoms. As a result, lone pair electron in a molecule occupy more space. So we will not leave any line of NCERT. ठीक है ना? So this you don't have to write, but you have to read. ठीक है ना? Like मान लो अगर छोटा सा क्वेश्चन just on the name of scientist we will frame ना, एक छोटा सा क्वेश्चन, small question, चिन्ना question, we can give you who explained the importance of lone pair and bonded electron pair, and they will give you option: Sidgwick, Powell, Pauling, Hitler and London, Newham and Gillespie. Now if you have not read the lines of NCERT, so what happened na, this scientist in 1957, they told this only. What they told, listen carefully, कि suppose this is A and B, one electron is given by A, one electron is given by B. These are what? Bonded electrons. These are what? Bonded electrons. Bonded electrons are between two atoms. A is also attracting it, B is also attracting it. A and B both are attracting this. So these bonded electrons are under influence of two nucleus. These bonded electrons are under influence of two nucleus. So they are more controlled. They are more attracted. They lie, the whole cloud lies between them, between the atoms. But the lone pair, if I ask you whose lone pair is this, you will say, sir, A. Is B attracting this? No. This one is attracted only by the nucleus of A. So what will happen? This will be a bit free. This will be a bit free, as this is attracted by only one nucleus. This is a bit free, free to move, not in control. It will occupy more space required. More space occupied. Like you imagine, when in class only one invigilator is there or only one coordinator is there, then what you do? If only one invigilator is there, people here, there, roaming anywhere, so much randomness is there. Take an exam going on, people cheating also. But suppose in class 3-4 coordinators are there. Now what will happen? Now everyone will sit on their place. They will not see this side, that side also. Same thing is happening. Bonded electrons are between two atoms. So they are strongly attracted. They lie between them. They occupy less space. They will not go here, there. They are here only. But the lone pair is attracted by a, fill in the blanks. Lone pair is attracted by a single nucleus. So it requires more space. So more space, that means there will be more repulsion. So from here we generate this order. From here we generate this order. See here, everyone see this part. Ki lone pair occupies more space. So we have a repulsion order which you will use in future. Ki lone pair repulsion is more than lone pair bond pair is more than bond pair. These are PYQ, gym material, very important. We will ask you in paper also. Why lone pair repulsion more? Because lone pair occupy more space. Lone pair occupy more space. This is only written here. So this was told by these two scientists. Redefined. Okay? So lone pair repulsion is more. So this we will use when we will try to tell you the shape of a molecule. Clear to everyone? So all the points of Vesper theory we have done. All the points of Vesper theory we have done. So finally we are moving towards shape of a molecule. Okay, what is the shape of a molecule? Now in NCERT you will find two tables given in NCERT. देखो आ जाओ. Two tables are given in NCERT. This is first table. This is first table where they are telling you about the shape without lone pair. No lone pair on central atom. Second one, they are telling you the shape including lone pair. Including lone pair. They are telling you about the shape including lone pair. Clear? Okay? So these two tables we will have to write, we will have to understand this. Once you have done, then okay. Clear? Let's move. So before doing this table, we will write first one more definition type, steric number. What is steric number? Steric number is number of sigma bond plus number of lone pair. Here we will write in future localized lone pair. But now we don't require, people may get confused, so I am not writing. It should be localized lone pair. When we will study resonance, then this word is important for you. Okay? So I am not writing, or let's write it. You ignore for now. Okay? So if anyone will ask you what is steric number, you can simply say sigma bond plus lone pair. Sigma bond plus lone pair. Okay? Let's come to the first table. First table, we are excluding lone pair on central atom. Lone pair on central atom we have excluded. Okay. Then I am making some columns here. First column I am writing general formula. Second column I am writing steric number. And third column I am writing here molecular geometry. ध्यान से देखो, molecular geometry. Or you can also say electron pair geometry. Electron pair geometry. And last we can give some examples of NCERT. Clear? देखो, these tables are most important. These tables are most important. अच्छा, these videos are online, so north, south, everywhere watching. ठीक है ना? Okay. चलो. So let's start. आ जाओ. So what we are saying, we are going to write the table. Like suppose this. Suppose I am writing here AB2. First of all, you will have to understand ki what do you mean by AB2. AB2 means A is the central atom. It is connected to two B atoms. A is the central atom. It is connected to two B atoms. Now it can be connected by a single bond, means sigma bond. It can have somewhere double bond also. It can have triple bond also. This side also double bond. Anything can happen. Anything can happen. But one thing is sure, कि there must be two sigma bond. There must be at least this much confirm or not. Yes. So AB2 means A is the central atom connected to 2B atom by 2 sigma bonds. This confirm. Total bonds I don't know, but 2 sigma bonds I know. So now I will write steric number. What is steric number? Sigma bond plus lone pair. Lone pair, so I have said that I will not include. So sigma bond, that means 2. Achha, now you have to try कि these two bonds, how I can arrange so that they will be at maximum distance. So you will say, sir, linear. Angle will be what? 180. So the molecular geometry will be what? Linear. Some examples of this, BeCl2, HgCl2. It's better to write the NCERT example. It's better to write NCERT example. Achha, now some people can ask, कि sir, How you know that this is linear? Huh? So at last of this topic, we will also take some questions and we will try to tell shape of molecule. We will try to tell shape of a molecule. Clear? Okay. Chalo. Now, I can tell you at least this much. Ki think like this. Ki beryllium is having how many valence electron? 2. One electron I will form bond with chlorine. One electron I will form bond with chlorine. There is no lone pair on me. So only 2 bonds. Sigma bonds. Linear. Done. Okay. Steric number 2. Sigma bond plus lone pair on the central atom. Lone pair I am not taking in any case now. Okay, let's go to the next part. Next part is AB3. AB3 means what? A is there, 3 B atoms are connected. So 3 sigma bond to confirm. 3 sigma bond confirm. Okay. Achha, now you think how to arrange 3 sigma bonds. So people will suggest this diagram. People will suggest this diagram. Okay, sir, you make a 120-degree angle. All angles are, this angle is also what? 120, 120, 120, 120. Total 360. This shape is known as trigonal planar. This shape is known as what? Trigonal planar. Examples you can write BF3, BCl3, AlCl3, all these things. Clear? देख लो. See here. You can also imagine like this कि मान लो suppose 3 friends bought one pizza. ठीक है ना, circular pizza. लो भाई, better circle I will draw. 3 friends, medium size, regular, large. Suppose you have brought medium size pizza, na? And you want to distribute among 3 people, 3 friends. How you will distribute? Honestly, you have to distribute. You don't have to do like this. Ki sir, first to half I will take. This is my. And rest half I will divide into 2 parts. This is not honestly. ठीक है ना? You have to divide equally honestly. Then you can say, okay, ठीक है, don't worry. Then what, sir? I will do what you know. I will divide this math. So I have studied something. So I will divide this into 3 equal parts. 3 equal parts means what? Center circle is 360 degree. I will divide it 120 degree. 120 degree, like Mercedes symbol you are seeing. 120 degree. Okay, na? So this shape is only known as what? Trigonal planar. Trigonal planar. Clear to everyone? देख लो. अच्छा, these both diagrams these both diagrams are in the plane only. देखो, I am having some pens also. I can show you here. These 2 diagrams are in the plane. Like linear is here. 1, 1 linear. So this is a planar diagram only. ठीक है? Many people do mistake when they ask कि अरे who is planar in this? When we will ask you question कि who is planar in this? People say, sir, trigonal planar. Why? Planar name written, sir. अरे planar means in a single plane. Linear is also in a single plane. ठीक है ना? 3 bonds you can think like this कि 1 bond here, 1 bond here, other bond here. देखो, trigonal planar. 120 degree planar shape. Clear? Okay. Now let's come to the next part. What is the next part? Okay. Let's come to the next part. Next part means AB4 type of molecule. AB4 type of molecule, that means what? Steric number is 4. AB4 type of molecule, that means steric number is what? 4. Okay. Now some people will say, what is the fault, sir? You have told though कि middle angle 360 divide by 4 parts. People will say, sir, this done. A is here, B, 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 B. Angle is what? 90 degree. Angle is what? 90 degree. Bolo. Good. No, not correct. So we can say कि sir, there is one more shape. You don't know. Here you are getting 90-degree angle only, na? One shape is there which is having 109.5 degree angle. More angle possible. More angle means what? More distance, less repulsion. So which one you will prefer? 90-degree angle or 109.5 degree angle? So we will take one. This is NCERT they are writing. Four bonds are there. Why you are not writing at 90-degree? Why you are making 109.5? Why you are having other shape, tetrahedral? So we will say in tetrahedral we have 109.5 degree. Okay? So angle is more, so repulsion is less. This one you are imagining. What is the fault here? You know, this you are imagining in 2D only, two-dimensional, 90-degree coming. You can go in 3D also, na? In 3D you imagine. In 3D you imagine this is tetrahedral shape. Chalo, I am making now normal way. This is tetrahedral shape. Okay, na? A atom is here and B atoms are here, and every angle is 109.5 degree. So this one is wrong, this one is correct, and this is known as tetrahedral. This one is known as what? Tetrahedral. Like methane, SiCl4, SiO2, all are what? Tetrahedral. Clear to everyone? Dekh lo. So now what is tetrahedral shape? Acha, all these shapes you can Google it out also. Okay, na? So 3D diagrams you can see. Okay, na? We will take benefit of others also. Okay. So dekho, although we can explain all the things by this pen only. Okay. Dekho, you have to think like this. Tetrahedral, one pyramid is there. At least you have seen pyramid in photos. So pyramid is there, and you think one more up. One more up. So that is what? Tetrahedral. Like see here. I have brought here 3 pens. 3 pens, one up. So this diagram is tetrahedral. This diagram is tetrahedral. This angle 109.5. This angle 109.5. This angle 109.5. This angle 109.5. 109.5. All angles are 109.5. It may happen in this diagram you are not able to see, but all angles are 109.5. Only all angles same. All angles bonds also same. All angles and bonds are what? Same. 109.5. This is tetrahedral shape. Clear? Acha. ठीक है, fine. SiO2, some examples also given, and now we know why we are preferring tetrahedral and not this diagram. ठीक है, done. Okay. Now what you will see na, till this point, till these 3 diagrams, in all the case we have one type of angle and all the bonds are same. Like here we have only 180, both the bonds are same. All angles are 120 and all the 3 bonds are what? Same. Same means what? Same bond length, same strength, like this. Okay. If you connect same atom, now this is tetrahedral, all angles are 109.5 and this bonds are also what? Same. Achha, here they ask one more question. Chalo, I am writing this question. Ki how many 109.5 degree? Achha, 109.5 can be also written many times as 109 degree 28 minutes. They write this also. Same. Okay, na? How many this much angle is possible in tetrahedral? Tetrahedral shape. Batao. Can you tell answer for this question? Those who have seen this question before, they can think, acha, this question is there. SiO2 is not linear. That's why I have written there SiO2. Okay, na? SiO2 is not like CO2. See, examples are also very important. I will tell you this. I have told you in covalent bond, I think, no? Ki diamond melting point very high, SiO2 melting point very high. SiO2 is not like CO2. Keep this in mind. ठीक है ना. They will ask you future hybridization also. They will ask in hybridization also कि SiO2 hybridization like CO2. No, hybridization is sp3 tetrahedral. ठीक है. So be careful. बोलो how many possible angles are there? So the answer is 3 plus 2 plus 1, that is 6. 3 plus 2 plus 1, that is what? 6. Okay. So Sudeshna writing Vardhan. Vardhan where? Pranitha writing. ठीक है ना. Vardhan asking question. बोलो भाई how you will get 6? Can you tell? How you will get 6? Huh? So again I will have to explain like this. See, देखो how I am getting 6. See, this is the tetrahedral molecule. ठीक है. Tetrahedral. You have to check like this one, black pen with 3 tetrahedral or not, means 109.5. Black pen 109.5, 109.5, 10 with 3 bonds, 109.5, 3. Done. Now you have to check this bond. This bond with rest 3, 109.5. But this one to I have already counted, na? Black one to I have already counted. So for this bond, 2 angles are left. 109.5, 109.5. For this one, only one is left. This one, because this I have counted. Black this we have counted. So that's why we are saying 3 plus 2 plus 1. So all possible angles, there can be 1, 2, 3, 4, 5, 6. So 6 possibilities are there. So you can think like this. Understood? Now finally, we will go to which question? TBP. The most important one, where we have most of the points. AB5, steric number 5, TBP, trigonal bipyramidal. Trigonal bipyramidal. ठीक है ना? So how to make trigonal bipyramidal? We say like this. देखो कि first you have to make a trigonal base. First you have to make a triangular base. See, this is triangular base. अच्छा, I will show you all the diagrams also online ना. In the next class चलो we will do. ठीक है ना? कि you can also find यार. This is not a big deal ना. So we will try to show you all. Don't worry. ठीक है? So this is trigonal planar. Like trigonal planar you are having. So all angles are what? 120. And then you will put one bond up and one bond down. This is known as trigonal bipyramidal. Trigonal bipyramidal, or shortcut we will write TBP. ठीक है ना? Example is like PCl5. Let's try to understand this shape. How we are getting this shape. There are so many pens in this room. I require 5. They are having 5. Wow. तो देखो, सबसे पहले first you will have to arrange 3 in trigonal planar shape. देखो, this is trigonal planar shape. ठीक है? You take a trigonal base. You take a trigonal base. You take a trigonal base. Put one bond up. Trigonal base. Put one bond up and one bond down. So this shape is known as. This shape is known as one bond up, one bond down. This shape is known as TBP. This is trigonal base. This is trigonal base. 1, 2, 3. Trigonal base. One bond up, one bond down. So here we have 2 types of angle mainly. Here we have 2 types of angle mainly. This base which you are seeing, 1, 2, 3. This base is known as equatorial bonds. This base is known as equatorial bonds. Can you tell me the angle between equatorial bonds? Bolo, tell. Can you tell me the angle between equatorial bonds? So 120. So this angle is 120 degree. And this trigonal base and this up one, this is axial. This we call what? Axial. So what is the angle between equatorial and axial? That is 90 degree. So two types of angles are there. These are equatorial bonds. These are axial bonds. This angle is 90 degree. This angle is what? 90 degree. So from this diagram, you will have two types of bond angle at least. Two types of bond angles are there at least. I can also say ki axial, how much angle is there? Then you will say, sir, 180. But mainly we will talk about these two bonds. So two types of bonds are there. That means there will be now different type of repulsion and there will be different types of bond length. That's why we say ki when you compare the bond length here, all the bonds are not same. Both are not same. Axial bond is bigger than equatorial bond. Axial bond is bigger than equatorial bonds. Again, I'm telling you, all these shapes, you can Google it out. TBP likh lo ki trigonal bipyramidal. And there will be variety, means this diagram, that diagram, you can check any diagram. Okay? Your choice. I will also show you in the next class, don't worry. Okay? So bond length, axial bond is bigger than what? Equatorial bond. Okay? All the bond lengths are not same. So all of you have understood how you can say pyramid, you know. See, trigonal base, one pyramid up and one pyramid down. One pyramid down. So that's why we say trigonal bipyramidal. That's why we say trigonal bipyramidal. Now people also ask, why axial bonds are longer? Can you tell me the reason for this? Why axial bonds are longer than equatorial bonds? Batao. Why axial bonds are longer than equatorial bonds? Can you tell me the answer for this? This is the last question. Done. Can you tell me this reason? If you will tell this reason, okay. If you will not tell, then this is your homework. Let's see. Pranita writing to minimize repulsion between equatorial and axial bonds. Repulsion. Chalo, good, very good. To minimize repulsion. To minimize repulsion between. Chalo, pura likh dete hain. Let's write all. Repulsion between axial and equatorial bonds. Okay? Like how you can understand this, you know? You can understand like this. कि मान लो suppose you are going and sitting in auto ये सब देखा है? Auto rickshaw, ठीक है ना? It happens, ठीक है ना? मान लो if you are sitting, so in the back seat generally there is a space for 2-3 person only. But the auto person, when you are going in sharing, so but the auto person will push 4 in that. 3 students space is there, but they will put 4 in that. Then how you sit in those places? You will find they will say like this, some people sit back, some people sit front. No? Have you experienced this? Maybe many people have not experienced it. But have you experienced this? Okay? Place is of 3 only. They make 4 people sit there. And then they say, some people sit back, some people sit front, a bit front, back and all. So this only why they are doing, to minimize problem. So here also what happens, you know, dekho, this is axial bond, this is having 90 degree with the equatorial bond. 90 degree with the equatorial bond. Their repulsion is more. See, equatorial angle is 120. So here repulsion is less. Axial equatorial angle is 90 only. So here repulsion is more. Again listen, equatorial bond angle is 120. Repulsion is less, more angle. But equatorial axial bond angle is 90 degree. Repulsion is more. So what happens na, this axial electrons try to run away. Kare, I will go away na, then distance will increase or not? Rocket launching type. So it is trying to go away. So that distance will what? Increase. So repulsion will be less. So like this they are trying. So enough for today. So read these things. You cannot do questions based on Vesper theory now, finding the shape and all. In the next class, we will tell you about shape also and a bit about hybridization also. So after that class, you can do so many questions. But as you are knowing all the things already, you can start doing questions also. Don't wait for last time. Revise all the things, and do questions. Whatever you can do based on this. VBT questions you can do, overlapping question, which one is zero overlap, which one is positive overlap, where bond can be formed, which overlap is stronger, in which case first excitation state is there, in which case bonding is done in ground state, in which case bonding is done in second excited state. So many questions are there. How many sigma and pi bonds are there? So all these things you can see. Clear? Dekh lo. So that's it for today. Enjoy your life. Any doubt, then tell. Okay, all good? Chalo. So be self-motivated and keep studying. Thank you everyone. Bye bye.